Okay, this is Math 2. We're doing 32 to 35 first, and then I'm going to press pause and we're going to continue on from there. So, first one. Solve each equation below for the given variable. Be sure to check your answers. You should be fine with A. If you're stuck on B, my biggest advice is to please put parentheses around 2m minus 1, because when you actually work that out, and if you want to cross multiply, you're more than welcome to, it should look like, let's see, 10 times 2m minus 1, oopsie, that's a minus, okay, is equal to 19m. All right, and then distribute the 10 and solve whatever answer you get. Does anyone need any help on C? Okay, so on part C, I need a little piece of paper really quickly. Okay, on part C, what you're going to do is figure out how to solve for P. So if, number one, you don't like P, then you can just change up to x's. So 3x squared plus 10x minus 8 equals 0. And, I don't know, complete the square. Probably not the best idea, actually. Factoring. Does that work out? Two numbers, that'll be 3 times a negative, what's 3 times a negative 8? 24. And then 10. Two numbers that'll multiply out to negative 24, but add up to 10. 6 and 4, 2 and 12. Ooh, that'll work. Okay, so 12 and... So let's see, positive 12 and 2, right? Oh, negative 2. Okay, so negative 2 and 12. So this is going to look like, let's see, 3x squared. This is not complete the square. This is just factoring. Same old factoring that you used to do back in chapter 3. So we have 3x squared, and then we have negative 8 up here, 12 and negative 2. So, I don't know, 12. I guess we could put the 12 here and then the negative 2 here. Does that work out? So 3x and x, negative 2 and 4. So x, sorry, there's an x's over here. So 3x times 4, 12x. That works out, I think. Negative 2 times 4 is 8. Okay. All right, so we have, sorry, you can't see. Okay, we have 3x minus 2, we have x plus 4, so split them up and solve. So 3x minus 2 equals 0, and then x plus 4 equals 0, and then you can solve your answer that way. Okay, so that was part C. And then part D, I don't know if you've actually seen ones that look like this, but for part D, you should realize that the only way you're going to get rid of this radical sign is if you actually square both sides. So squaring both sides or squaring underneath the radical just gives you an x plus 2 equals 25. And then just solve for x, basically, from there. Okay, so that was 23. Next part is 33. Ooh, yay. Here we go. 33. Charmaine sold her bicycle to a friend for $200 cash. She put her money in a drawer and forgot about it. 3 months later, she found the money and put it in a 5-year CD, which is certificate of deposit, which actually do exist at banks. If you ever know, you can actually put money in a CD. Account that earns 2% annual interest compounded yearly. Write a piecewise defined function that describes the growth of the money over time. Make sure to define your variables and restrict the domain appropriately. Okay, so I'm going to draw a picture of what this actually looks like first, and then you can sort of take it from there. And then we're going to write our piecewise function. So the first thing is money-wise. So we have it at, she has $200 in cash, right? So for 3 months, it's not doing anything. It's just sitting in a drawer. Right? So her money is just kind of hanging around. It's a flat line. 3 months, it's not doing anything. And then all of a sudden, she's going to put it in the account, and it's going to turn 2% annual interest. And if you're not familiar with well, in this case, exponential functions is the name of the game, especially when you're talking about compound interest. So at some point, her money is going to start becoming an exponential function, which means it's a curve. It's not a parabola. It's not a line. It's exponential in growth. You should somewhat remember this from last year. The only question is, when does it actually start to do this? So we know it was in there for 3 months, right? But 3 months with respect to a year is 3 out of 12, because 3 months out of 12 is your goal. So what's 3 divided by 12? It's 1 over 4, right? So 0.25. So 0.25, 0.25th of the year, of that year, in years, that's your domain. And then she leaves it in an account for up to 5 years. So all we know is that this money is going to be growing exponentially, right, for up to 5 years from 0.25 and then on. Okay, well, that takes care of your domain. Okay, so your piecewise function is going to stay at $200 for 3 months. It's not going to move anything. So between 0, including x, less than 3 months. So in this case, it was 0.25, because that's how much 3 months was. And then the other one, it's going to go from 0.25, and then up to 5 years. So x was your years. Your years. Wow, not your ears. Okay, the only question is, what's the function for the exponential? And, well, here it is. I don't really know how else to do this unless I just give it to you. So you start with $200, and you earn 2% annual interest from up here. So 2% added to 100%, since when you are adding money, you are actually adding to 100%. So 2% plus 100% gives you 102%. 102% as a decimal is 1.02. So your multiplier is 1.02. And since it's an exponential function, it's actually to the x exponent in general. And if you were to graph this on Desmos, that's what it would look like. Your piecewise function is, okay, it's doing nothing for about 3 months, or 0.25 of a year. And then from 0.25 to 5 years is actually growing exponentially in the account. Okay, that was 33. Okay, 34. Okay. In Chapter 8, you encounter Choose Your Shape pizza parlor that sold circular and square pizzas. Each area of the slice of the circular pizza is 15.4 inches squared. The circular pizza has slices with area of 0.125 feet squared. Okay, and then when we were doing this in tutoring, this is the part where I was super confused about. So basically, the name of the game is to make sure your conversion has the same units, because then you'll be able to tell which has more area. So the slices is in feet, the pizzas with the squares in feet, the inches is in, well, the circular is in inches. So the question is, do you want to convert from feet to inches, or do you want to convert from inches to feet? And my advice is to convert the feet into inches, because we know how to work backwards. Sometimes it's hard to work the other way around. So you have a circular pizza, and I'm just going to, draw a picture of what this looks like. There's your circular slice of pizza. The area of the shaded part is already 15.4 inches squared. So you don't have to actually find it. It already tells you that the shaded, or the slice of pizza, is 15.4 inches squared. And the area of the slice of one of the square ones, right? I think this is what it looked like. This slice, or one of these slices, is 0.125 feet squared. Okay, so here's how this is going to go. To go from inches to feet, you usually divide by 12, right? So from inches to feet. But we want to go the other way. We want to find the inches. So we have to actually multiply by 12. So here's what we did. We did like, okay, well, 125, right? Multiply by 12 should give you the inches. So 0.125 multiplied by 12 is something really silly like, I don't know, 0.125 multiplied by 12. Okay, 1.5, right? But then, as we were doing this in tutoring, we realized, wait, that doesn't make any sense. That's not a big aha moment because that's already smaller than the 15. So there's no way that the area is only 1.5 when it was already low to begin with when it was in feet. An area of 1.5 inches squared doesn't make any sense because it's still smaller. There's no point to this problem then. So then we realized, oh, wait a minute. It's not 12 because 12 is the linear scale factor. And area from, I hope you remember the potato chip problem. The linear scale factor, it doesn't have anything to do with the area. The area scale factor is actually the square of the linear scale factor. So you take 12 and you square it and you get 144. That's the area scale factor. Okay, 1 times 144 instead, because 12 squared is 144. So 0.125 times 0 times 144 is actually 18 inches squared. So 1.5 is just inches. That was like if I really were thinking about it in terms of perimeter of the pizza versus the area of the pizza slice. So if you're paying the same amount of money for the circular one and the square one, technically you should go buy the square one because you get more pizza versus the circular one, or in that case, the slice of pizza. Okay, so that was 34. And then one more 35. Ooh, 35, yes. Ooh, 35 was fun. Okay, after doing well on a test, Althea's teacher places a gold star on her paper. Oh, that's so nice. When Althea examines the star closely, she realizes that it is a regular pentagon surrounded by 5 isosceles triangles. So that actually does help us because a regular pentagon means that we can find out what each of the interior angles add up to. So let's see, we have 5 sides in the pentagon. So 5 minus 2 times 180, that should give us 3 times 180. 3 times 180 is, what is that, 540? Is that right? Okay, 540. So 540 is what each of these interior angles add up to because, well, it's 5 sides. Now, because each side is the same, then I can take 540 divided by 5 and get 108, if I remember correctly. So that means because each side is 5, I can divide by 5, or each side is the same, since it's regular, we get 108. Now, if you look really closely in here, this is going to be 108. This is going to be 108, this is going to be 108, this is going to be 108, this is going to be 108. Okay, so all of these are going to be 108 on the inside. So now, question is, what is this angle out here? This is going to be our goal. Here's x. Because if you can find one of them, they're pretty much all the same, so it doesn't really matter. Your clue is obviously the fact that this is an isosceles triangle. So, if those are both 108, if you take 180 minus 108, you should get, what, 72-ish? Okay, so that means this angle here is 72 degrees, since that's a line. That means this angle here is 72 degrees, since that's a line. That's 72, that's 72. There's your x. So subtract from 180, and you should be able to find your angle right there. Okay, that was 32 to 35, and in the next one we'll do some of the other ones.